Hello everyone. Also welcome from our side. We're here today to talk about building data mesh on Databricks and Azure for large manufacturing companies. Before we dive deeper into the topic, we want to share some context with you. So since about 2 years, ThoughtWorks supports client in manufacturing on their data mesh transformation journey. About 1 year ago, we started to build a data platform to support data product development. And at that time exactly, also Dominika and I joined the project. And here at the top, you can see our team composition. So we're working in co-delivery mode, which means we also have developers on client side. We are a cross-functional team. And I want to especially highlight that we have about 4 development pairs, if this is our usual working mode, working in pairs. And we have colleagues with data background, data engineers, and also cloud infrastructure engineers. This team is not only developing the data platform, but also owning the very first data product. And so, which means that we develop data platform capabilities alongside capabilities for the first data product as well. So where are we at the moment? So our first data product is live. We are currently onboarding new teams onto the platform, and migration activities are also underway. So we are going to talk about data mesh today, and data mesh, in a very short introduction, is a socio-technical approach to managing analytical data at scale. And this socio-technical word means that it's both technical and organizational. And today we are going to focus only on the technical part. This is also why this 4th principle, domain ownership, is grayed out on this slide, because this is fully organizational one. So for the other 3, we have data as a product. And this one is all about how you should serve your analytical data. So you shouldn't anymore serve it by throwing files and tables on some central data lake and then wait for people to find it there and make use of it. But instead, you should build data products. And in a very high level, from a very high level point of view, data product is a microservice, which is, as every microservice, tailored to the consumer needs. Then we have self-serve data platform, which is a platform that is supposed to make building these data products easier and faster for the data product teams. So it's all about self-service and automation. And as every platform, it's there to reduce cognitive load of the teams, in this case, data product teams. And then we have the 3rd one, federated computational governance. This one is very much organizational, but it has also some technical component in it. And this is this computational word. This means that we should also automate governance policies. And of course, this automation is part of the platform offering. So this is a very short introduction to the technical part of the data mesh, for sure not comprehensive. So for those of you who are not very familiar with the concept and need more details, you can scan the QR code in the bottom right corner, and it will take you to the Introduction to Data Mesh article. But what we want to talk about today and show you a bit from our project is how did we translate this theory into the design of our system, and how did we use components we had available in our technology stack to implement our data products and implement the platform. And we will start from data products. So in theory, a data product consists of data, obviously, a code that processes and serves the data, which is a good old ETL pipeline, but in this case has a scope that covers only this one data product. And of course, the infrastructure on top of which all of that runs. In our project, when we started it, there was already a technology stack chosen for us. So we joined the project and we learned that we are supposed to build data mesh, which means self-serve data platform and data products, on a stack that is on the left side. So our cloud provider is Microsoft Azure, which offers us a storage service called Azure Data Lake Storage. On top of that, we have Azure Databricks and also an offering from Databricks called Unity Catalog. And we are supposed to design data products that are isolated from each other, as the theory says, and, for example, have output ports. So, of course, we started from what is our infrastructure, what are our infrastructure pieces. So whenever you need to build a data processing software or any kind of software, you need to decide on the storage layer and the compute layer. And in our tech stack, the storage is offered by Microsoft Azure in a form of so-called storage accounts. Storage accounts may be seen as something like S3 bucket for those of you who are more familiar with AWS. So it's a resource, our infrastructure resource. On the other hand, we have Databricks that offers us compute resources, and these are offered in a form of so-called Databricks workspaces. So Databricks Workspace is an infrastructure resource that lets you spin up compute clusters. It lets you run Spark jobs on these clusters. And also it offers you a UI interface, which looks like what you see on the right on this slide. And this interface has a unique URL and also some additional features, like, for example, notebooks. And in these notebooks, you can, for example, write SQL code and query your data. So how we designed our project data products is that each of the data products has a separate storage account and has a separate Databricks workspace. Of course, they are connected through networking, which looks small on this diagram, but it's also a bit of work to get it right and to get it secure. On top of that, we have Unity Catalog. And Unity Catalog gives us metadata services. So it lets us organize our data into catalogs, schemas, and tables, and also gives access control features. So for us, each data product has a separate Unity Catalog. That also means that each data product is free to design their schemas however they want. And under this, they are free to design their table views and also other so-called lowest level secureable objects, which can be volumes for non-relational data. Also, tables and views are our output ports. So this is how we model them. There is a nice feature in Databricks that supports all of this design, and this is called Workspace Catalog Binding. And it lets us configure a catalog to be visible only from a specific workspace. So it also gives us isolation between data products. Another feature we use is access control given by Unity Catalog. And what you see on the slide is a fragment of Terraform code. Terraform is our infrastructure as code technology. And you can see here how you can use Terraform to grant privileges to a specific output port, which is called output port 1. This is what is at the bottom of the slide. And you give select privilege to the data reader group. Terraform is just one of the interfaces Unity Catalog gives you. You can also do this using SQL interface or by using Databricks SDK, which is available, for example, in Python. Now, what is this Databricks users and group data reader group? So this group is part of the internal Databricks identity management system. And this system is integrated with cloud providers' identity management. In our case, it's Microsoft Entra ID. This one is integrated with our client-side Active Directory and client-side identity management system. All that means that whenever a user wants to get access to an output port, they just go and use a system at the client side, which they use for any other access request. They ask for being added to the data reader group, and all that gets automatically synchronized down to Databricks users and groups. And because of the code you saw on the previous slide, it gives them a select privilege to the output port table. So to sum up this part, for us, infrastructure of the data product is Azure Storage Account and one Databricks workspace. Then the code of the data product is a Spark job running in Databricks workspace, and the data are Unity catalog tables.
Yeah, now that we just learned how we mapped data product onto our given tech stack, we now want to focus on the second principle. It's about self-service data platform. And for that, I want to invite you to join me on a journey, on a very specific journey, the journey of a data product development. So imagine we are all part of a manufacturing company and are tasked to build the next generation of flywheels. Flywheels going something like this in the lower right corner of the slide deck. And now you somehow realize that a certain generation of flywheels tend to break more often than others. And so you naturally start asking yourself why. What might be the reason for that? And then you somehow get the idea. So what about when we take a look at the stage where the flywheels have been produced, have been manufactured? And as there's also this really cool new data mesh initiative going on in your organization, you come to the idea, okay, now that would be a cool use case for a new data product. And this somehow summarizes already the very first step of the data product developer journey. It's about getting ideas, incepting, exploring, and also identifying sources for a data product. Also, bootstrapping is part of this, which we will present you also in a second. Then, after this initial phase and an initial data product is there, the data product team will start building the data product, testing it, deploying it, running it. And then you also see those cycles here. This is always in a cycle, you can imagine. And towards maybe the end of the lifetime of a data product, or once the initial build phase is over and the development is the initial development is done, then there's time for maintenance, evolution, and at one point even also retirement. So as we are very shortly on our data mesh journey in our project, we don't focus on retirement yet. We want to focus now on the bootstrapping phase and the second phase, and show you how we implemented this so far. So as you see, there should be a demonstration, but apparently it's not working now. But believe me, we have I will walk you through what you should have seen. So we provide a template, which is based on Cookie Cutter. And this data product template contains a so-called Hello World data product, a skeleton data product, which can be used to initialize a data product development. And we leverage overall 17 questions. Those questions encompass, for example, the name of the team. And FWT was used here. It's the flywheel team. The name of the data product, manufactured flywheels, for example. And we also have to configure here then the infrastructure that is needed. So Dominika pointed out in the beginning, we provide Databricks workspaces. We also provide service principals in order to run the workloads securely. And all those things have to be answered in the questions. And after then all questions have been answered, the first Hello World data product is there. And so basically, you now see here some screenshots of our code after the questions have been answered. And so the core of our data product, Hello World data product, is based on Databricks Asset Bundles. And Databricks Asset Bundles is a framework to bundle together, to summarize together features to develop, test, and deploy code to Databricks workspaces. And so the core of this is also the code to so-called Databricks YAML file. We specify some targets here. So there's, for example, a development target, a QA target, and a prod target. Hinting already that we do not provide only one workspace, but 3, because we support 3 different stages here. And so we there, for example, see the configuration of the workspace ID, also the service principal ID, all that has been entered by the questions answered in the during the bootstrap phase. The next part is about this was one too much. I tried to plan. Okay. About the job YAML file. So this is the configuration somehow about the job itself. So first, the Databricks YAML tells you how to deal with the artifact in each stage. And this specifies now how the job should be configured. So you can imagine this Databricks job that runs in workflows. Workflows is something like an Airflow, an orchestrator. So we define, for example, the name of the job, about concurrency, when should it run, what is the task that should run. And here you might already see that we use a Python wheel task here. So we ship the code as the Python wheel and let it deploy through bundles to the workspace. And also, for example, the resources. So how large should the cluster be on which the workload should run? And the main code for now is still very, very, very simple. So we basically only print the count of a table that is of a samples table that is available with every Databricks workspace, and serves here for now as a Kickstarter and to somehow show our ideas on how we think or how we want our data product teams to start their data product development. Yeah, so now code is there, tests are also there, even though we didn't show them, but they are there. Now, how do we get this code to the workspace? For this, we use the Databricks CLI with the bundle command, and especially the bundle deploy command. -T stands for the target, and this specific command deploys the bundle to the productive target. This command you can run it from local or from the OCI pipeline, and in either case, then the deployed job gets to the workspace. And this is how it looks like. So we are in the workspace again, and we are in this area of workflows, and which is one part of our data product data as a product, as Dominika pointed out. And you see, for example, manufacturer flywheel, MFW, FWT, flywheel team. Maybe you remember this from our beginnings, where we started our journey as a data product developer. There are details on the job, on the compute cluster, and so here only one job was run, but when this job runs for several times, you also see a time series here. So this is the output of the job, just the row count, as we also saw in the code itself. You get the status of the job, how it was launched, in this case manually, how long it took, and so on and so forth. So this should have given you some kind of an idea on how we envision the data product developer journey so far. And with this slide, I want to summarize this overall process. So we are at the bottom here, and the data product development team, our flywheel team, is sitting here, and now they have this idea and they want to build this new data product. And so they reach out to the data platform team and align on the creation of the new data product. The data platform team then uses the infrastructure blueprint to create Databricks workspaces on every infrastructure here. We also configure a Unity catalog, and then the developer takes over and can use the template we provide and fill in all those 17 questions, and then also get the code in the repository, get a ready configure Jenkins pipeline, and also a configuration file to an in-house catalog to publish information about the data there. So this is the first part about the bootstrapping part that you can map. Can you see mapped here? And the second part starts, so to say, the development phase. And this is your usual development flow. So we do some changes, we commit our changes. Each commit triggers Jenkins, run in Jenkins, and which deploys code into the workspaces, which then, in case the ETL pipeline is there, also generates data, which is accessible through Unity Katan.
So that was the self-serve data platform and an example of how we support and automate creation of a data product or initialization of the data product. So what Rika presented is what we hand over to the data product team, some Hello World ETL pipeline, and we let the team implement the rest. And now let's move to the third principle, federated computational governance, and this idea of automating governance policies. So this is just one example of how can you do this and how we do this. So let's assume we have a policy that says that we store all our data within the European Union, which is, by the way, a requirement in our project. So how can we automate such a policy? So our idea for that is by using a tool that is called Open Policy Agent, OPA. And this is quite a sophisticated tool, but in the high-level overview, it is something that lets you define policies in a language called Rego, and then it runs these policies against any kind of structured input, for example, JSON, and then it gives you the evaluation result. So in our case, we already mentioned that we are using Terraform as an infrastructure as code technology, and Terraform can give you something called Terraform plan, and this plan can be in JSON format. It is basically a file that describes all the changes you are going to do on your infrastructure, so creation of new resources or updating the existing ones. And this is what we run through Open Policy Agent. And on the other hand, we have a lot of files in Rego language that describe our policies. And this run is part of our infrastructure creation pipeline. So whenever we have a request from a data product team to create infrastructure for new data product, we run the pipeline and we check if all the infrastructure we're going to create conforms to the policies. If not, the pipeline breaks and we don't continue. So in our case, OPA is a way to enforce governance policies. Here you can see an example of the Rego language, and we are really crazy about test-driven development, so we are super happy that this is also supported by OPA. So in Rego language, you can write both your policies, but also unit tests for them. So you can have a test suite that checks if your policies are really doing what you want them to do. And what you see at the top is the unit test. We start from test. And in the code, you can have a look that we have a test input that looks like a fragment of Terraform plan for the storage account creation. So you see here that the type of the resource is storage account. And in our test data, we just set the location to a string invalid location. And then in line 11, we say that we want to have a rule that is called deny resource not in Europe West. And then we run this input through this rule, and we expect the rule to fail and say that this is the invalid resource location. So this is a unit test, and below you have a code for the rule itself. So you see here that we react only on a resource type storage account, and we extract all the fragments of Terraform plan that contain storage account operations like creation or update. And then we just check if the location is Europe West, and if not, we fail. So this is one of the ways you can automate governance policies, and that's how we are doing in our project.
Yeah, and with this, we want to briefly already close this talk and share some learnings and challenges we faced during the last year. So we will present this on two different levels. One is a very specific technology trap we somehow fell into, and what it meant in our case. And the other is sharing a bit about lessons about implementing a self-serve platform for a data mesh. So let's move on to the technology trap. So there's a peculiarity in Azure when you use Databricks, and especially the Unity catalog in Databricks. You see here a screenshot from the docs saying that you basically can have only one Unity catalog meta store per Azure region. That in the end means that there's only in our organization, there's one central team that owns the Databricks account, which can create this meta store and then also catalogs in this meta store. The roles that Databricks or Unity Catalog provides are not very fine-grained, which means that this central team will not hand over any permissions on account level to us as a data platform team. And you can already imagine what happens. This definitely disrupts the automation of data product infrastructure provisioning. So once the initial workspaces are there, we somehow have to stop the automation, reach out to their team, and give them some further input so they can create catalogs on our behalf. Then we take over again and have to do another steps, another manual steps until we can hand over this infrastructure. And so this is a bit about disruption of data product infrastructure provisioning. So moving on to the other lessons about implementing a self-serve data platform. Here on the left-hand side, you see a screenshot from Zurich Security Best Practices for Azure Databricks. So this is a list that contains 38 items and which you should follow in order to have a very secure workspace. And as we take security really it is very important for us, and we take it really serious, which also means that implementing security recommendations just takes time and effort. So we are in the game for about a year now developing this platform, and you might have noticed there's one data product live for now. And this is also a reason, because we really also have to spend proper time in implementing a secure and well-designed data platform. Maybe you remember from the beginning our team composition we have in the team, and that we work cross-functional, and we somehow have a fair and good split between infrastructure developers and data engineers. And we also somehow learned over this year that this is very effective in the phase we are currently in a very early phase of implementing data mesh, where there's a platform and first data products are building on it. And also the idea that the platform team also owns the first data product is also tied to this very initial phase we are in, and also in our case works also very well. So in the end, that means that that Dominika and I we can wear different hats during development. So once we can be data platform developers, and for other stories data product developers. So we more or less become our own customers and know very well what the other party needs. And this served us very well so far. Yeah, with that we would like to thank you for your attention and are here for your questions.